The views, thoughts, and opinions expressed in the podcast belong solely to the hosts and not the host's past, present, or future employers. All right, good morning, good afternoon, good evening, everybody. This is Brian from Bringing Down Security. Mr. Betcher, Ms. Berlin joined me this week.
Hello.
Hello.
And wow, Brian sounds like he just woke up. And that would be my wife, my lovely, lovely wife, who's printing something on a fucking printer. It's 8 a.m. my time, Pacific time. We got up this early because our interview this week is halfway across the world, 9 time zones away, so or 8 time zones. I don't know. Math eludes me at this time of day.
Lots of time zones.
It's a lot of time zones. Yeah. So I'd like to welcome Shlomi Oberman to the show.
Hi, everyone. Happy to be here. Thanks for inviting me.
Right on. So, Shlomi, tell us a little bit about yourself. Everybody's got an origin story, how they got into this industry. Maybe we could find a little bit about how you got to where you're at today.
Right. Sure. So today I'm at JSOF. The company recently found the Ripple 20 vulnerability you may have heard of. I started in this industry something about 10 years ago, take. As many Israelis, I'm based in Israel, based in Jerusalem, Israel. So as many in this industry, I started in the military, the IDF. I did some cyber stuff there. Started just I started I think a little bit before they started calling it cyber security or started using cyber so much. So I started just as information security. I sort of like to say that I've seen cyber from all different hats, seen it from the offensive side, defensive side, like the network operator side, the product vendor side, etc. And I've dealt most of the time with just very super niche area of software vulnerabilities. So truth be said, like we don't deal with any type of like IT security or anything of that sort. We just do product security, which is what both me and my founder have been doing for like past bit more than 10 years each. And I've done a lot of security research. I find the research super interesting. So a lot of reverse engineering of esoteric platforms, a lot of vulnerability research and assessment, a lot of exploitation stuff. That's one of the reasons we started this Triple 20 project, because we have to pay the bills. So we do a lot of consulting on secure development and secure processes and stuff like that. But the research is always super interesting.
Cool.
So,
okay.
Yeah.
All right, cool. So the reason we had you on, or having you on, and your team at JSOF is a report or a white paper that came out called Ripple 20. So I have a couple of questions about Ripple 21. Why did you call it Ripple? And 2, there's 19 vulnerabilities in the white paper, so why 20?
So that's well, we called it Ripple because of the amplification effect. We think it sort of ripples through the supply chain. So Treck is a TCP/IP stack by this small American company, presumably not the type of product you'd look for a vulnerability in. But then they sold it to quite a big bunch of companies, and those companies, many of them resold it to other companies, who resold it to other companies. And so the impact of the vulnerability grew and grew and grew, and they've been selling it for 20 years. So we see it as sort of rippling out from the center, which is Treck, the company, the TCP/IP stack, all the way to all these products like medical products, infusion pumps, like industrial control devices, utilities, power grids, transportation. We've seen some railway stuff, enterprise printers. So from this little point, which turns out to be an epicenter, it ripples out into like all different parts of IoT and technology. So that's the ripple part. We initially had some other candidates, such as Snowball. I think that was one. There were a few others. Don't remember all the others. But we went with Ripple. We thought that captures it well.
Cool.
Our company, what's the word? Like the one line is exploring the depths of security. So we thought that Ripple also works there, works with that. Regarding the 20, anyone who's ever counted vulnerabilities as part of a complex disclosure, it's not a straightforward process. So these 19 vulnerabilities, there's actually 24 patches, something like 22 issues that Treck issued. So they're calling it 22 issues internally. And then 2 of these vulnerabilities were not actually reported by us. They were reported anonymously. And we were asked to sort of include them in our report, and because we were reporting all the other vulnerabilities anyway, and sort of spread them out with the other vulnerabilities so everybody gets the information, all the vendors that need to fix. And it just so happened that we ended up with 19 CVEs rather than 20 or 22 or 17 or okay. Could have worked out differently. I'd go with, Treck has a bunch of vulnerabilities. Many of them are critical. That's right. If you need a number, 19 is the official number. But there's actually so many. And actually, Treck is super configurable. So that's actually what we're going to be talking about at Black Hat this year. We're going to go into depth with one of the vulnerabilities or one of the CVEs. And so how it's actually 4 different vulnerabilities in the background. Oh my. But each device has a different variation because they're each compiled differently. They each use a different version of Treck, etc. So that's the origin of the ripple and why there's presumably 19 vulnerabilities, but it's actually somewhere between 17 and 24. Well, the 20 is, so we have a holiday called Passover, where we do all kinds of strange things, and we say it's so that the kids can ask questions and learn about the holiday. So we figured a funny name would elicit questions. That's the official answer. No, the official answer is because 2020, it's 2020, so report 20 for 2020. The unofficial answer is we just didn't want it associated with COVID-19. So we figured if we'd call it Ripple 19, that might not have a good association. And so we opted for going with the year instead of the 19 vulnerabilities.
That's fair. Ms. Berlin, I'm going to let you ask the one of the first questions we've got here in our show notes. We have a lot of questions based on parts in the report, systems that were affected. Some of those were, called out before, but go ahead and give it a start, and I'll finish up with my really small cup of coffee.
So when you started communicating with Treck, were you surprised at their initial reactions? And talk about that a little bit. Did they have mostly a positive reaction? I had heard that they originally had a negative one, right? Until they found out that you weren't just trying to exploit them.
So I wouldn't say they had a negative reaction, but they were very suspicious at first, not very communicative. At the very start, I don't remember if they didn't answer at all. Their answers were very short. We couldn't find an email on their site. I think originally we emailed sales@treck.com because that's the only email we could find. If I recall correctly, we didn't get any answer to that. And then we located a customer of theirs who made an introduction, and then at least we got talking. And I think they've just never been approached by independent security researchers. So they didn't know what to do about it. Yeah, and we sort of said, listen, we want you guys to report to your customers. We think you can tell the story better. we think it might be beneficial to you, and we don't want to be the ones that talk to your customers directly, which in retrospect maybe was bad wording because it probably sounded a little bit like a shakedown or something of that sort. We saw their lawyers, poking around their LinkedIn. We got very slow email communications, but slowly things started smoothing out. And also as some of their clients got involved, we talked to HP, we talked to Intel, we talked to Digi, and then we talked also to the SOAR organizations, and all of these sort of helped them figure out that this was, part of modern life for any software company, and that it's a beneficial process for everyone, especially the end users. And this happened a lot later, but they actually ended up benefiting from this financially because a lot of their customers renewed support. I don't know how that's going to work out going forward, but in the end, the communication was very, I don't know if you call it very positive, but it was positive and correct, and they worked with us to fix and push the fixes out, etc. They weren't very open and transparent, so it's not like they gave us a list of their customers and said, look, these guys might be affected. They notified their customers on the one hand, and then we had to track down the different companies separately. But they did take on the heavy load of notifying all the customers together with the coordination agencies, and then we also did some.
That's interesting that you said their lawyers got involved and started poking around, right? Did they look at your social media, things like that for your employees? And also, I think it's interesting, you or your people started contacting their customers. So it's like both sides kind of did an end around, right? Instead of talking to each other directly. Is that what happened?
Yeah, so we started talking to the customers, both because we sort of weren't getting, at first, I think we weren't getting responses at all, but either way, we weren't getting fast or what we thought were relevant responses. So that's why we started talking to the customers saying, hey, you're vulnerable. We also wanted some kind of, right, now obviously these vulnerabilities have been vetted by hundreds of thousands of people. Everybody's been acknowledged that they're severe, etc. At first, when you find vulnerabilities, right, we only did reverse engineer 5 or 6 different products. So we wanted to talk to these companies and make sure that we're not making a mistake here, that these companies are that they understand it, that what we're saying here makes sense. So that's part of the reason we talked to these customers. And with some of the customers, we didn't actually report all the vulnerabilities. We just said, hey, I think there's a vulnerability. Please make a connection to Treck so that we can talk to them. So we were I think that was even before we got an answer from Treck, before the lawyers got involved, just sort of finding some way to reach Treck.
So you mentioned Intel and HP. What kind of systems are we talking about here? I mean, HP does printers, they do computers, they do all kinds of items. I believe during our pre-discussion of the podcast, you'd mentioned IoT and some embedded systems and industrial control systems. How many companies are we talking about that uses Treck, and why is a custom, why is Treck so popular with these companies?
Right. So if a company builds a product that is based on a real-time operating system or just bare metals, no operating system, they'll need some way to communicate, right? If they're a connected device, what we call an IoT device, right? The I part, the internet part needs a connection. And so they need a TCP/IP stack. And many real-time operating systems don't come with one. And then they have a few options to choose from. And Treck is a leading provider. So they buy a Treck license. And then some of the companies will say, okay, we don't even want to deal with having a TCP/IP stack or anything of that sort. We'll just buy a module that does all of this, offloads all this. But then that module also needs a TCP/IP stack. Like the DigiConnect modules, which we researched as part of this project. And then the DigiConnect uses Treck, and they're vulnerable. And so just by incorporating that module, they become vulnerable as well. An example is some infusion pumps that incorporated a Digi Connect product, or maybe it wasn't a Connect product, but a Digi product. And they were also vulnerable because they incorporate this product. And so it's even worse than incorporating like a binary blob. They just took a physical device, put it in their infusion pump. In this case, it was the battery, and the battery was vulnerable. So their whole product became vulnerable. So that's why you need a TCP/IP stack and why it's become so widespread. They were also there when the internet started to sort of expand rapidly, right? They've been around for over 20 years. So they've been selling this product for 20 years, and it's become more and more widespread.
Okay. So I woke up this morning and I got a really large cup of coffee and decided, I was going to do a podcast. When you woke up one morning and said, "Hey, I just want to go ahead and poke around on this TCP/IP stack," what's precipitated the decision for that? Were you asked by a customer, or you just, found something interesting when you were poking around one day and decided to take the rabbit hole down to Wonderland? Well, what made you want to, poke at this TCP stack in particular?
Yeah, so we're a small boutique consultancy. We're 12 people today. We serve customers mainly in Israel, and we were sort of me, my co-founder, and our COO. We were sitting and thinking about how what's the next step? How we start working outside of Israel? What's our marketing plan? How do we start developing sales out of Israel? And one of these things we thought about, which would both be, in the spirit of the company of being research oriented, as well as could have a big impact, was to do some independent research and publish it. So the original thought was, let's get our name out there outside of Israel. Let's do some interesting research, generate some content, and publish it. We didn't set out to research something as big as Ripple 20. We didn't realize we were going to be affecting devices. We think there's Ripple 20 devices in every medium to large organization in the US, right? They'll all have an HP printer or a Brother printer or a Xerox printer or an AMT device or an Aruba switch, or they'll all have one of these devices at least, we think. But we did want to do some research, showcase some of our capabilities, what we do, etc. We started with some smaller research about HP printers, which was part of Ripple 20, right? We had to reverse engineer printers to find the stack. We did some research on one of the devices involved, and then we saw the TCP/IP stack in this device. We were going for supply chain research at the beginning, and we thought we had this device that was in the beginning of a long supply chain, but then we realized, hey, there's this connectivity module, TCP/IP stack. So this is even earlier in the supply chain. This affects more devices. Let's look at that. And then we took a look at that, and we started finding vulnerabilities.
Okay. All right. So I was doing a little research, because I was like, how many, there can't be that many custom TCP/IP implementations out there. I found more than a few, and also found blog posts, which we've put an example, one called Pico TCP, and then there's a whole blog post series about how to build your own custom TCP/IP stack. When you started doing these, what difficulties did you have when doing the analysis for these? Did you have any specific deadlines? Did you have issues with tooling? And maybe you could discuss some of the tools that you used when doing the analyzing of the stack. Was it just regular code audit stuff, or did you use fuzzers or Wireshark or anything interesting like that to analyze this TCP stack?
So the Treck TCP/IP stack is proprietary. and they keep their source code very close. So there was no source code involved. It was all just reverse engineering of different devices, and just correlating that with some information found online, etc. We did work with a timeline. We knew we were hoping to go to Black Hat 2020 with the research, so that was a deadline. We didn't know if we'd get in at the time. We didn't know what the results would be, but we knew that we'd want to try and apply for that. So a lot of reverse engineering that was quite complex. And then something else that was quite difficult was that the Treck stack is super configurable. So there's no two versions of the Treck stack that look the same. And it exists in all kinds of strange devices. So we had to reverse engineer these devices, and then we had to reverse engineer several different devices to understand. Like at first we thought we found vulnerabilities. We looked at a different device, they were closed. So we said, okay, this is not a 0-day. This has already been closed. And then we said, okay, but it's a 1-day that exists in a lot of devices in the wild, right? Not everybody's closed it. Then we reverse engineered another device, and we realized they weren't closed. It's just different devices compiled differently. So if you look at the advisories of the different vendors, like every vendor has like 6 of the vulnerabilities, or they have 19 of the vulnerabilities, or they have some subset of the vulnerabilities because they compiled differently. They stopped updating Treck at some point. So we had to reverse engineer several different devices to just figure out what was going on. So that was the most complex. We used Ghidra quite extensively for the reverse engineering. One of the devices we reverse engineered device. We had a lot of trouble with the architecture because they used an Intel architecture that is very similar to the x86 Intel x86 that we know, but it was a non-Intel x86. So we had quite a hard time dealing with that architecture at first.
Okay. So you might have heard a bleep back there. Some of the vendors that are going to be mentioned potentially have not patched everything. So I'm going to go ahead and, for terms of OPSEC, I'll go ahead and bleep that vendor back there. So you mentioned extensibility. What are we talking about in terms of extensibility on a TCP stack? I mean, I'm imagining these days a marketplace where you'd go in and be like, oh, I want a different TCP IP size, or I want to be able to make puppies come out when something happens. I mean, what are we talking about in terms of extensibility?
So these different devices, they have to comply with or have to adhere to. They have a lot of constraints, these devices. They want certain functionality, they want it at a certain speed and at a certain code size. So Treck implements, it's what we're calling a fully featured TCP/IP stack. They implement IPv4, IPv6, UDP, TCP, ICMP, tunneling, fragmentation, DNS, ICMP, HTTP, FTP, IGMP, PPP, Ethernet. So they implement a bunch of protocols. And then you can go to Treck, or I suppose this is how it works, and you say, listen, I only want IPv4 and ICMP. And I don't think I need to support fragmentation because, I don't want to support that and I don't want to pay for that. And then I don't need SSL and TLS because my clients don't need that, and I don't have room in my on my flash device for any extra code. So that's what I want to buy. And then you can compile it with different, you can say, okay, I don't want to use your memory manager. I want to use my memory manager because I have a really good memory manager. So, I'll leave that out. And then I don't need to make any code changes. So just compile it for me, and I'll take the binary version that's cheaper anyway. So that's, one device. And then a different device can say, I want it all. I want IPv4, I want IPv6, I need TLS, I have to support fragmentation, and I need the source code because I'm implementing some custom features. So there's 100 flavors of Treck.
Okay. So you a webcam may only have so much space on the flash memory or the file system, and they need a pared down TCP that only does certain things. So I mean that's about the limit of my IoT knowledge, I think. But yeah, so that makes sense. I guess if you don't want to support spanning tree protocol or whatever, you wouldn't put that in there. So that would make sense. And like a network switch might have more than that. So I've asked enough questions right now. Mr. Betcher, please feel free to hook it up.
So what happened after you submitted these to them? Did they work with you well? Did they fix them all? Are they all? I know you published your white paper, but what are the companies that bought this? Do they supply updates or whatever?
So once we were sort of on track, Treck took some time to fix the vulnerabilities, which I appreciate. There are lots of vulnerabilities, so it takes time to fix them. I think it was something like 45 days until they issued patches to all these vulnerabilities. Later on, they had another additional patch for one of the vulnerabilities, where the patch was slightly incomplete. And then within 45 days, they started notifying their clients about the issues going forward. So we weren't very involved in fixing the vulnerability. That's sort of not our side of the equation. But at this point, we were wrapping up our research, documenting, still communicating with some of the vendors. We started looking, finding which vendors are affected online and through other methods. So I'd say as soon as we got on track, it was a good flow.
Cool. Ms. Berlin?
Do you know of, or are you looking into other vendors like TCP/IP stacks to see if maybe they have the same kind of issues, or did that send you down a rabbit hole of now I want to look at this kind of stuff?
So that's actually super interesting. Sort of as part, we're probably not looking at any more TCP/IP stacks at this stage. I think we've done that, and we'll leave that to someone else. There is some follow-up research we might do, but very minimal. But when we were doing this research, we did look at some other TCP/IP stacks for reference, for understanding. And with one of these issues, quite interestingly, we found that this one specific feature was probably very difficult to implement, and we've seen I think it's 3 other TCP/IP stacks that made similar mistakes at this point. Just one of these issues, not as bad, not as critical, smaller stuff, smaller TCP/IP stacks, different mistakes, but it's pretty interesting. We're probably going to publish a blog post about that, and we'll publish the vulnerabilities. So we do have 2 additional vulnerabilities, sort of in disclosure or about to be disclosed. As soon as we find time for it. In other TCP/IP stacks, which was just a side effect of this research, because we noticed that there's this one thing where it's just difficult to implement. So Treck made a mistake, but some others made a mistake as well. And I think this is not the last TCP/IP stack vulnerability, right? I think these IoT vendors should really get together, pull up the money and ask someone to review the TCP/IP stacks they're using, right? There's 80 different vendors using this TCP/IP stack. They could, fund a review of this code, make sure it's secure, and and avoid the next ripple. Just now we saw something in Microsoft DNS stack. So that's also sort of TCP/IP stack vulnerability. So I think there's more coming. Not by us, but I think there's more coming. I think somebody else will take the next TCP/IP stack and research it.
Did you find anybody that's doing it really well?
So we didn't look that much right and left. We just looked for references. We found some that we thought would do it well, which is why we looked at them for reference and made mistakes. I can say that we didn't find any issues at Linux, but we didn't look that hard, right? We only spent 2 hours there just looking for some reference code. So we haven't found anything really well. I do know of a TCP/IP stack. I've seen a lot of people, or I've heard of a lot of people that tried to find vulnerabilities and didn't. It's one of the proprietaries, but we didn't do it ourselves, so I can't really speak to what that means about the TCP/IP stack.
Cool. Yeah. So once you reached out to Treck and built the relationship that you have with them, did they eventually give you access to source code, or did they have any specific requirements in terms of, hey, thanks for finding all these vulnerabilities. Could you go look over here and do this? Or did they say, well, hey, we're not going to give you any source code. This is going to be off limits. Was there any restrictions or limitations once you went to them with their findings?
So there was no source code involved. They didn't give us any source code. We wouldn't want to receive any source code. We don't need any source code. I mean, would have saved us time doing the review, but right. Obviously then we'd have to pay them and sign an NDA, and we couldn't publish our research. So that was, the source code is theirs, and maybe we're saying we didn't do a review of the whole TCP/IP stack. So I imagine that's what they're doing at this point. Mm-hmm. They're probably either internally or externally doing a review of the source code, finding additional vulnerabilities. So this sort of thing doesn't happen again. At least I hope that's what they're looking into. And a few people have actually asked us about this. Like they saw a report, which were pretty complete, and they said, hey, how do you get the source code? But it's just GIDRA doing decompilation. And then some of the vendors compiled the code with symbols. So we got function names, etc. And then that was very helpful. And we correlated that with like public Treck documentation, stuff on the internet. So we just sort of sourced information from different places. They didn't ask us for anything additional. They did ask for some additional scripts. For some of the vulnerabilities, we provided less documentation than others, just because some are more severe than others. And we sort of figured it's better to, report all of them and, then not report some just because we don't have the time to generate scripts, etc. So,
Okay.
So I know some malwareans compile their malware with debug information. Is symbols the same as debug information, or how is that different?
Yeah, so exactly the same. It's debug information. Just because different vendors buy the source code, they can compile with debug information or without, and then maybe they're supposed to compile it without. I don't know, but they compile it with the debug information. So we had that, and that contains like function names and all kinds of stuff like that, like debug strings, all kinds of things.
Right on. So are your, everybody likes using things like Shodan and to go even further back, things like Nmap to do scans online, looking for vulnerabilities or vulnerable machines. Every time there's an RDP vulnerability, people are, I found 8 million instances of this online, using Shodan or whatever. Are these vulns that you've published in the white paper such that they can be detected online, or is it, require just a fingerprint from, this vendor or, the device that's being ran?
So these vulnerabilities do route, as we call it. You can exploit them over the internet. And I guess you could detect vulnerable devices through Shodan, like on the internet, just by, some of them you could detect by searching for like Treck FTP server, that might work. And then others you'd have to just look for the different like HP printers, this vendor, that product, that for this vendor, the other product. Just look for the specific products. We weren't actually we didn't go too much for the show them aspect, because we think that the main issue here is not necessarily exploiting these vulnerabilities over the internet. Most of these devices are critical devices in your enterprise network, and that's the attack vector, right? We're talking about sophisticated attackers already in the network, and then they use these attacks to cause damage to an infusion machine, cause damage to the power grid, or hide from antivirus and security.
Shlomi, can't hear you anymore. Your audio's down.
Can hear
Is
you.
that better?
Fine.
Okay.
Brake, it's just you.
Yeah, it says my connection's unstable. Great. Because I only live in, Seattle, so. All right. Well, go ahead and please finish your thought there. I had some audio connection issues there, so sorry about that.
So we just didn't really look at devices being exploited over the internet, even though it looks possible. People shouldn't be connecting their critical devices to the internet in most cases, and should be doing it with a really good firewall if they do. Some of the reporters asked us about this, and we sort of did a quick search, and we gave them some numbers. We don't find that to be the interesting aspect. The interesting aspect is your nuclear reactor connected to a PLC that has Treck, and then you don't want that vulnerability even if the attacker is in your network, rather than, oh no, my printer's connected to the internet, so just don't connect it to the internet. That has nothing to do with Treck or Ripple 20. So that's the attack vector we think is more relevant.
Yeah, but my nuclear power plant, I need to be able to, use my BlackBerry to move the neutron rods while I'm sitting at home watching, Yellowstone or something. So, that's important to have my fucking nuclear reactor sitting on the internet. Jesus. So I'm looking through your white paper here, and you mentioned IP tunneling. Is that important for a lot of these IoT devices? Why was that specifically called out? You also mentioned IP and IP. Is there a reason that this was called out in your white paper?
Yeah. So the white paper is about two specific vulnerabilities at this stage, or two specific CVEs. And these vulnerabilities require the IP and IP feature to be enabled for the vulnerability to be exploited.
Okay.
That's the reason it's there, and not all the Treck devices implement this. We're going to be releasing a second white paper about another one of the CVEs. That's a DNS vulnerability. Mm-hmm. And then all the devices that have DNS will be affected by that vulnerability. Yeah, something else interesting about the IP tunneling and the IP and IP, this is actually something sort of new from the app and from a couple of days ago, maybe yesterday or the day before that. Somebody asked, a prominent security researcher asked us whether the security vulnerabilities route over the internet, which we never checked, right? Because we didn't think this was too important for us. And then the researcher working on this, Moshe, he wasn't able to get the packets out of our network because we have a firewall. And then instead of turning off the firewall, he figured, well, what happens? Treck supports IP and IP. And if you put IP and IP, it will send the packets to itself. So I could just put all the packets, wrap them in another layer of IP, and then they'll just be normal IP packets. And then, they'll evade the firewall. They'll travel over the internet. So yeah, so we definitely know that they travel over the internet, and that's using IP and IP feature.
Okay. But like you said, that doesn't work on everything, just only on ones with that specific configuration.
Right. No. So it's just like a subset, like maybe I don't know, something like 20% of the devices, I guess, something like that.
Right. So you've got a number of vulnerabilities. Is there any are they categorized in any specific way? Is it like poor coding practices, or is it, just network stack issues, or is it code? What kind of classification would we give a majority of these vulnerabilities?
So almost all of them are memory corruption issues. Maybe all of them. No, I think almost all of them are memory corruption issues. I wouldn't call it poor coding practices, because it's important to remember that these vulnerabilities were written 20 years ago when these were considered good coding practices, or, nobody thought about security that much. I think the bad practice here is not reviewing the code for 20 years. And that's, actually, I think that's mostly on the vendors and not on Treck, because, Treck were asked to supply a fast, good, small, configurable TCP/IP stack, which is what they supplied. And then, it's quite surprising that all these big vendors that supply to end users and critical utilities never thought to ask, just a minute, when did you last review this code for security issues? Maybe we should review this code for security issues. So they fall into the category of bad coding practices today, but when the code was written, I think it's completely understandable.
I think it's not just a small company thing either. That happens a lot, pretty much everywhere. If you've been in business for longer than 5 years.
Yeah,
definitely. So everybody has vulnerabilities, and it happens. And the larger your code base, the more vulnerabilities you have.
Right.
I mean, the DNS thing has been since 2003. So
yeah. I was about to say 17 years old vulnerability, and it's not the only one we've seen. We've seen other vulnerabilities, not just from Microsoft, but other companies. It's been, 15, 20-year-old vulnerabilities that have been sitting inside the code. So
was it like System D when they went back and started diving into that stuff that that's been around for forever?
Yep.
So we know these. Yeah.
It's expensive to do a code audit, and it's like, well, it's out there, it's making us money. So why do we have to go back and spend money to review it? It's a business decision that ends up as a big expense, right? And that's why it's not done. It's not thought about.
Yeah.
I mean, why would you want to spend money on something that's working properly?
Yep.
Right. It just doesn't make sense from a business perspective. But then again, if you know what potential consequences there could be, right? You get totally owned or whatnot. I guess it comes down to you bought this code, you trust them initially, and you release it, and you don't think about it after that.
Well, it's not just it's not a trust thing. You may not even know you're running it. You've bought this widget, you've bought this webcam. You don't know that you're running a TCP/IP stack, or a file system driver, or the Chinese camera inside of your baby monitor. You don't know what kind of driver it's running or what kind of code it's running. So you don't really know what you don't know inside of your, and sometimes maybe you just don't care. You just want a $5 webcam, but you're getting what you paid for, right?
I think that segues nicely into our second part.
Yes. I do have
Good job. Good job, Brian.
I appreciate that, but I do have one question I'd like to back up. So once you've went to Trex with all of these vulnerabilities, did they start their own internal code audit? Did they give you some kind of after action? It's like, oh, thanks for the vulnerabilities. Here's $5, and, are they starting a bug bounty program? Are they starting any kind of, regular code audit? Do you have new customer? I'm not saying that they brought you on as a customer or as a vendor for testing, but I mean, are they improving their own processes after you've shown them all of these things? Or did they even tell you?
Yeah. So I'm sad to say I don't really know.
Okay.
They did everything they should be doing, but they weren't very open or transparent. So we don't know what their process is for security. And remember, this company was completely unknown for 20-something years, for 22 years. And that's how they made their business, by being unknown, the company nobody heard about, super reliable TCP/IP. There's never been any issues. It's not going to come back to you if you buy this TCP/IP stack. And then one made them famous, right, for 15 minutes. And when we when this went public, their website fell for 20 minutes. So it's like they don't want to be public. They don't want anyone outside of their customers to know what's going on. We do know that they opened a security@treck.com email address, which is a good sign that they do have some kind of policy on security vulnerabilities. And I do imagine that their clients force them to, do some kind of, have some kind of product security response. Like if somebody reports a vulnerability, make the process more streamlined next time. My guess is that they're not doing a serious security audit, because as Brian said, it's expensive, it works. I think TCP/IP stack should probably be the exception, because even if it does work, the balance of the cost versus the impact is so big that it makes sense, to spend that money on the review. It's like this very basic, super dangerous component. But yeah, so we don't exactly know, but the fact that they have a security@treck.com now at least means that the next security researcher won't have to sort of track them down and find a connection to make an introduction like we did, etc.
Right. And you've opened the floodgates. So, now that this white paper has been done, there's blood and water for all the sharks out there to be looking at that. That was our show for this week. You can find show notes for this and all of our shows at www.breakingsecurity.com. You can also find an RSS link on the site to add to your favorite podcatcher. You can find all of us on Twitter. Miss Berlin can be found at InfoSyster, INFOSYSTIR. Mr. Betcher can be found at BetcherPwned, BOETTCHERPWNED. And you can follow me on Twitter at Brian Brake, BRYANBRAKE. We have a Slack. Come join us on our Slack. A lot of great things going on there. A lot of channels of various InfoSec-related subjects. You can get an invite on Twitter by emailing our official Twitter handle for the show at Brakesec, BRAKESEC, or you can email us at bds.podcast@gmail.com. Thank you to all of our Patreon supporters for their monetary assistance by offsetting costs involved in putting out a weekly show. Zoom fees, Libsyn hosting, domain purchase, renewal, equipment upgrades, time and effort building the community we have. We appreciate all of your help and support. If you'd like a t-shirt, stickers, coffee mug, or just to show your support for the show, you can check out our TPub site, www.tpublic.com/user/BDS podcast. We thrive on your feedback. A quick 5-star comment on iTunes or Google Play Store or your favorite streaming service, Spotify, Pandora, what have you, go a long way to gaining us additional visibility. It takes no time at all, and we appreciate your help in spreading the word. That was it for Breaking Down Security this week. Be safe, be well, be kind to one another, take care of yourself because you're the only you have, and we'll talk to you again soon.